Hello, ladies and gentlemen. I'm Yuan from CSADI. As a structural engineer, I'm working on the design of high-rise and large-span public buildings, and also includes some hospitals. I'd like to thank IABSE for giving me this opportunity to report what we did during the epidemic. Today, my presentation is about rapid design and construction management of emergency hospitals during the COVID-19 epidemic. I'll begin with the construction concept of emergency hospitals, and then I'll introduce some relevant design guidelines and standards. Finally, I'll take the Stuttgart Mountain Hospital as an example to explain the key points in design and construction. The COVID-19 global pandemic is a serious crisis and challenge for the entire world. Facing this unexpected and devastating disease, China launched a battle to prevent and control its spread. We have adopted extensive, stringent, and thoroughly containment measures, and succeeded in cutting all channels for the transmission of the virus. These are the 5 stages of China's anti-epidemic process, and the construction of emergency hospitals we will talk about is concentrated in the 2nd stage. The COVID-19 epidemic was first manifested in Wuhan. So where is the first city to build emergency hospital in China? Since the outbreak of COVID-19, the number of newly infected people in Wuhan increased sharply from January 21st, and Wuhan closed the city urgently on January 23rd. At that moment, Wuhan's medical system was facing pressure to improve the reception and treatment capacity. Wuhan decided to replicate Beijing Xiaotangsan's hospital in 2003 and build emergency infectious disease hospitals, namely Stuttgart Mountain and Stuttgart Mountain Hospital. On February 3rd, 2020, Wuhan Epidemic Prevention and Control Headquarters decided to implement the policy of patient classification. A total of 3 different lines of defense are deployed. The first line of defense refers to the hotel and schools that are mainly used for accommodating isolated people. The second line refers to makeshift hospitals that are mainly used for receiving and treating patients with mild symptoms. The third line refers to the temporary emergency hospitals that are designated hospitals that are mainly used for receiving and treating patients with serious symptoms. With the spread of COVID-19, a large number of emergency hospitals have been built, transformed, or expanded all over the country. It's difficult to count the number of hospitals completely, but these hospitals can basically be divided into 3 categories. The first category is temporary emergency infectious disease hospital, featuring lightweight and modular assembly. First of all, you can see the picture. Wuhan has 2 famous temporary emergency hospitals. That is Stuttgart Mountain Hospital and Stuttgart Mountain Hospital, replicating the design concept of Beijing's Xiaotangsan Hospital in 2003. These 2 hospitals adopted the unitized layout and modular structure. These are the facilities inside the emergency hospital. We can see the word patient passage, laboratory, CT room, and operating room. This is emergency hospital built on the original site of Beijing Xiaotangshan Hospital. Compared with the original conditions in 2003, we can find that great progress had been made. These are the cases from Shenzhen and Xi'an, and we can see that their forms and layouts are similar to those in Wuhan. In the process of design and construction, design institutes across the country have proposed a relatively unified layout and structure form through cooperation and exchange. Two special cases are worth mentioning. One case is that the emergency hospital in Zhuhai adopted the reinforced concrete structure for the first time. The main structure was completed in 9 days. It can be used permanently and withstand typhoons. The other one is the highly integrated container-based modular system for infectious disease hospitals. It is developed by BSB and can be built into a high-rise building and used for a long time. Its factory fabrication takes a little longer time, but the field installation is very fast. The second category is the makeshift hospital, which is also known as the Fangchang Shared Hospital. In response to the COVID-19, China adopted the makeshift hospital for the first time. It is a large temporary hospital to separate patients with mild symptoms from their families and communities, and provide medical care, disease detection, accommodation, and social activities. It can receive and treat a large number of patients during the peak period of epidemic, make full use of existing buildings, and transform them into temporary treatment places in the shortest time and at the lowest cost. This is the distribution map of some makeshift hospital in Wuhan. The circle size is proportional to the number of hospital beds in each makeshift hospital. This diagram shows the changes of bed capacity and occupancy rates of the makeshift hospital over time. Since February 18th, that is 12 days after the first makeshift hospital in Wuhan began to accept patients, the number of confirmed cases in Wuhan has steadily declined. So the makeshift hospital is a major reason for China's successful control of the epidemic. In addition, the third category is the transformation of existing hospital wards. The general wards are transformed into negative pressure wards. The flow organization are adjusted, and the clean area are separated from contaminated areas. This transformation should be completed quickly with the least change. In the process, some new standards and guidelines on emergency hospitals and makeshift hospitals were formulated on the basis of the existing standards for hospital construction and prefabricated building in China. These are existing construction standards for infectious disease hospitals, which had formed a relatively complete standard system. These are existing national standards for prefabricated buildings in China as the basic support of the building industrialization system. Temporary emergency hospitals are suitable for prefabricated light steel structure, which makes full use of the standardization, modularization, and integration of prefabricated buildings to meet the requirements on rapid construction under the emergency. All the above are relevant specifications and standards. During the COVID-19 epidemic, there are also many new technical summarized, and the following standards are released at the early stage and have guiding significance. First, the design guidelines for emergency treatment facilities of novel coronavirus pneumonia, which is applicable to the reconstruction, expansion, and the construction of medical facilities, and specifies construction principles and requirements of site selection, architectural design, structure, E&M, operating and maintenance. Second, the design standard of infectious disease emergency medical facilities for novel coronavirus pneumonia, which is also applicable to the design of reconstruction, expansion, and construction. Third, the guidelines for design of temporary hospital for infectious disease, which is based on practical experience from the construction of Weigard Mountain Hospital and the Stuttgart Mountain Hospital. Then, the technical requirements for converting hotel buildings into temporary hospitals, and the technical requirements for design and conversion of makeshift hospitals, which were released to relieve the current epidemic situation as soon as possible. The one about makeshift hospitals was translated into English and published for reference of international counterparts. Now, I will take Stuttgart Mountain Hospital as an example to explain the key points in design and the construction. First of all, we should ensure the urban environment is safe and the site selection is reasonable. The hospital is located in the south of downtown areas and at the downwind position of the city in winter. In addition, the surrounding area is broad land under development and construction without any residents. Municipal facilities are relatively complete. The site is flat and the ground is hardened, making it suitable for temporary construction. This is the master plan. The construction land of Stuttgart Mountain Hospital covers an area of 220,000 square meters and includes east and west blocks. With a total building area of 79,000 square meters. The core area is an isolation area in the east block, which can accommodate nearly 10,500 patients. The living area for medical staff in the west block can accommodate about 2,300 staff members. This is the typical architectural layout of the isolation area. It adopts the fishbone layout, which can be flexibly adapted to the site. The layout follows the principle of 3 area and the dual passages for typical infectious disease hospital. 3 areas refers to the clean area, the semi-contaminated area, and the contaminated area, with safe passages provided between different areas to ensure the safety of medical staff. Dual passages refer to the patient passage and the medical staff passage. The patients may enter directly from the outside. Each ward and treatment area is relatively independent to prevent cross-infection. Next, I will show you a video of beam simulation. This video demonstrates the inner space of the ward and the treatment area, and show the stand-in outflow of medical staff. Okay. The Stuttgart Mountain Hospital is constructed in these 3 stages: the modular design, standard production, and the prefabricated construction. First of all, let's take a look at modular design. The ward module is a major functional area. Each ward module had 50 beds. All ward modules have universal and consistent design. The 3 basic functional modules are assembled into 30 wards as per unified internal standard. To achieve standard production, the whole isolation ward and treatment area is divided into 2 box-type modules of different size. The yellow ones with a plain size of 3 meters times 6 meters, and the blue ones with a plain size of 2 meters times 6 meters. On the basis of modular design, different parts and components are produced in a standard manner. When workers are treating the ground and burying pipelines on the site, over 10 factories across the country have already started the module fabrication. Most building materials of the hospital are prefabricated in factory. They are all produced in a standard and industrialized manner. This is the unit of container house, are composed of modular floors, roofs, and the wallboards. The cold band thin wall profiles are used as the main materials for steel structure frames. In addition, the mechanical pipelines, doors and windows, and the decorative parts can be incorporated alone into the module units. This is the on-site installation process of the container house. Taking the box body as the basic unit, this modular unit may be combined together to form a much spatial area. By removing the partition walls between, they can be flexibly installed either in an integrated manner or assembled on the site. The medical technology zone mainly includes ICU, CT room, operating room, and so on. These function rooms need large span and height, and the column grids are not unified. The steel frame structure is used because it's difficult for container house to meet the requirements. In the design process, a detailed model is directly established to facilitate the rapid construction. And the structural checking and the detailed design are carried out at the same time. With this approach, the process from design to drawing is shortened to 24 hours. The steel structural members are cut and fabricated and immediately transported to the site for assembly. Next, I will introduce how to achieve rapid construction from the perspective of construction management. The rapid construction requires two key factors. The first is coordination of design and construction, and the second is construction management and resource allocation. Good coordination of design and construction requires, first of all, the integrated project management concept, that is to take the EPC mode as a reference and consider design issues from perspective of construction and procurement. It's necessary to use the existing resource of construction contractors and adopt the existing materials. The design scheme should be proposed on the basis of full awareness of construction conditions and status on the site. If the condition change and makes it hard to implement the original design, the scheme should be timely adjusted. Secondly, it's necessary to arrange different design process seamlessly and coordinate with the construction. Thirdly, the well-adapted and flexible structural form should be selected. Moreover, the structural form should be simple, reliable, and convenient for fabrication and installation. In addition, the on-site design and the effective communication are also indispensable. The quality and safety risk should also be controlled during the construction and coordinated with the acceptance inspection. The site and foundation are main factors that restrict the construction period. To start construction as soon as possible, the design should utilize the original hardened ground as much as possible. The area lacking hardened ground should be paired with thick concrete hardened layer and provided with built-in steel mesh. The hardened ground should be integrated into a whole and provided with piers or wraps according to the superstructure. This method can not only solve the problem of crushing for the foundation, but also provide good conditions for laying HDPE waterproof membranes over the whole site. The container house is lightweight, and the hardened ground can bear the load from it directly. It's elevated to a certain height by piers to ensure the installation space for drainage pipelines. Meanwhile, rafts should be adopted in the steel frame area. We can find from the figure that strip-shaped concrete piers are arranged along the outside of the buildings to support the superstructure and block the backfilling soil. And edge-shaped steel piers are used inside. There are 5 difficulties to overcome about construction management. First, to cope with the limited construction period, it is necessary to formulate a detailed implementation plan and improve the management increase inputs of labor, materials, and equipment, and arrange working procedures reasonably. As for quality control, the on-site personnel should be arranged at any time to enhance the quality management. It's also important to decompose the quality objectives and guide the workers with samples. Third, equipped with sufficient construction technicians to improve the design, conduct the technical review, and adjust the design in time according to the site conditions. Fourth, subcontractors should be managed by established systems and agreements, and should be subject to progress analysis. In addition, their working requirements should be satisfied. Finally, as for resource allocation, it's necessary to establish a quite functioning allocation department to ensure that the resources are fully utilized and mobilized throughout the country due to the lockdown during COVID-19. We can get some information from the overall construction schedule of isolation area. Construction of the site and foundation take up over 1/3 of the total time. Therefore, the optimization of site treatment measures had a decisive impact on the construction period. The second, highly integrated container house costs only a short time, but electrical and mechanical pipelines in bulk is the main factor that restricts the construction period. Although the industrialization and assembly of building modules are relatively high, the integration between building and MEP equipment still depends on field installation, and the workload is very heavy. In the future, key functional modules, such as negative pressure ward unit for infectious disease hospital, can be developed and manufactured in a standard manner. During the construction of Sandgard Mountain Hospital, BIM technology and digital simulation, prefabricated construction technology are adopted. On the one hand, they can avoid the collision of electrical and mechanical pipelines. On the other hand, it's also used to digitally simulate the on-site construction procedures to guide the installation of module components, optimize the assembly scheme, and improve the efficiency. We also have adopted the CFD simulation technology, established a large-scale city-class flow field model, and simulated the influence of exhaust emission outside the hospital on the surrounding environment, which provides the basis for the overall planning and the design of the hospital, considering the health and safety of medical staff, patients, and the public. The analysis of air distribution in the negative pressure ward aims to find the best scheme for air supply and exhaust, thereby facilitating the rapid circulation and the exhaust of contaminated air and reducing the risk of cross-infection. Finally, I'd like to make a conclusion with this presentation. In the battle against COVID-19 epidemic, temporary emergency hospitals and makeshift hospitals have made great contribution. With the remission of the epidemic in China, these hospitals completed their historical mission and shut down successfully. The rapid construction of temporary emergency hospitals benefits from The rapid construction of temporary emergency hospitals benefits from the concept of modular and prefabricated construction. The collaborative management and resources integration capability. The modular and the prefabricated construction system has the irreplaceable application value and the enormous development space. In the future, various modules will be developed to satisfy different function demands of medical facilities. And the integration of E&M will also be improved. In the meantime, the experience of makeshift hospital conversion reminds us that the design of public buildings should not only satisfy the requirements for normal use, but also meet the demands in the epidemic period and keep sufficient conditions for emergencies. Well, that's it from me. Thank you very much.